Okay, everyone, welcome to our Routing Switching Essentials Instructor Class meeting. Today, I will be using my service book, so it's a little different. I can write on here, which is kind of neat. I've got chat up here in case we need it, and we'll go from here. But we're going to talk today about VLANs, which is a function of switches that allows switches to be broken into logical or virtual LANs. Separating each individual port, possibly each individual port from one another, or a series of ports with one another. VLANs are extremely useful because it allows us to take a network that would be one flat broadcast domain and traffic that would be visible to multiple users who may not see it and break them into different groups. For instance, you're looking here. This is a network that consists of 3 different VLANs, at least 3. There's probably a 4th one for management also, but at least 3. In this case, we've got a faculty VLAN, we've got a student VLAN, and a guest VLAN. With VLANs, you end up with, because of these, what we end up calling virtual tags, you end up with the traffic being tagged with, and we're going to talk about, there's 2 different types of tagging out there pretty much, but there's ISL, which is older and really no longer used, and there's .1Q or 802.1Q tags, and we'll show how that works. But traffic as it comes in, nothing's tagged out here on the access port, but once it gets to the switch, it becomes tagged with the tag for that particular VLAN. Ports that are in VLAN 10 are the only ports that can directly receive information from VLAN 10. So if PC1 sent a broadcast out, PC 2 and 3 would never see it, because once it comes into the switch, it's tagged as part of VLAN 10. And you would see that would actually come up if this was a trunk link to here, and would go out to this. If this is a trunk link, it would come over here and it would go out to VLAN to PC4. But because these other ports are not in VLAN 10, they're in a different VLAN, they're in a separate VLAN, they would not get the tag. They would not get the information. I'm going to change. They would not get the information. They would be in a different color or a different tag. So it's a way of increasing security because we can separate the traffic based on our logical VLANs. You can reduce costs because instead of, if you wanted to do this type of separation before VLANs, you would literally had to purchase 3 switches in each one of these instances. You would have had to have a switch for faculty, a switch for students, and a switch for guests. You can get better performance because you decrease the size of the broadcast. Well, you may not technically decrease the size of broadcast domains, but many times you do. It's more efficient, and it's more, you can manage items easier. I will tell you that it used to be that we carried, let's imagine, I'm going to do this again. Let's imagine that this is our core right here. So this is one building. Let me change my color back to red because I think it shows up better. That's one building. That's our core there. So we've got that. And then there were other buildings out. So this would be, let's say this is a technology building, you know, and maybe an allied health building or something. So allied health building. And this is a core, which may be an admin building. In the older days, one of the things that we would do is we would actually build out a layer 2 network to each individual building, and we would expand our VLANs across multiple buildings. Now what we do, it's more likely you're going to find that we route between buildings, even on campus networks. So VLANs are, this would be one building, and then that would go routed down to the core down here, and that would go out to other buildings. So VLANs, other than like our wireless VLANs that get moved out through and tunneled back, the VLANs are significant inside of buildings only. And that's just because we found it to be more efficient not to move that layer 2 information throughout the core of our networks. There are some typical VLANs. One is a data VLAN, and that is a VLAN that moves, obviously, data that is on the network. By default on a switch, all ports are in VLAN 1. That is a security issue, and one thing you'll learn about is that we typically try to move all of our ports into what's called a black hole VLAN, or a VLAN that is not used by any data, and it's a special VLAN we create and then put all unused ports into it. So if someone would happen to plug into it, they would not have access to VLAN 1. This is also why we don't use VLAN 1 for management. if all ports are in VLAN 1 and you forget to move one for some reason and you're using VLAN 1 for management, then someone could plug in there and see all the broadcast traffic on VLAN 1, which would be your management VLAN, and possibly sniff other management traffic. So we avoid that as much as possible. The other types of VLANs are native VLANs, and we'll talk more about this. Native VLANs are, the best way I can explain it to you, it is a non-tagged VLAN going across a trunk. So, and we'll talk more about that as we move along, but it's a little bit interesting. And then we talk about management VLANs. Management VLANs are those switch virtual interfaces that we put onto the switch to allow us to do management. Our examples we've used in this course so far have been VLAN 99, and that was the VLAN that was assigned. You do interface VLAN 99, give her an IP address, and that would be the IP address that would be used for management for the switch. Used to be you could only have on 2960s one active SVI, but with version 15 or higher, you can now actually turn on multiple SVIs inside of on a 2960 switch. SVIs on a higher level switches, you can have multiple SVIs because many of those switches actually support layer 3 routing, which will mean that we wouldn't have to have an external router to route between VLANs. You could do it on the switch itself. Other types of VLANs, this is something we actually talked about last week. We talked a little bit about how when you've got a phone, the phone has a built-in switch right here, and so there's a MAC address for the switch or there's a MAC for this. Ooh, that's terrible. Left-handed. I am left-handed, so be aware. There's a MAC address of the switch inside the phone itself, and then also the MAC address of the PC. So if you were doing port security here and set it to just one, and you had a phone and a PC, it would actually go air disabled because, or however you set it up, it would cause a port security violation. But what you can do here is you've got different VLANs, one for voice, so that it will tag voice traffic with one VLAN and also apply quality of service to that. And then it will tag the data traffic from the PC with a different VLAN, in this case VLAN 20, and it would have a different quality of service. This allows your phone to talk back to the call manager server and do phone registration, call setup, call teardown, those types of things using the voice VLAN. The example Cisco almost always uses the voice VLAN is 150, so I don't know if I would do that in the real world because of the fact that it can cause issues. Now, when we start talking about VLANs, we're going to look at trunking. Now, we're going to learn there are two types of ports. There are access ports and there are trunk ports. I'm going to sit my laptop down so I'm just drawing it. These ports right here are what are called access ports. Access ports do not have tag traffic on them, so there are no tags maintained. No tags maintained on access ports. Okay. My handwriting is horrible. All right. Now on trunk links. Okay. So this is a trunk. You'll notice that we've got VLAN 10 on both sides. If PC1 wanted to send a broadcast and have that received by VLAN 10 on the opposite side, that trunk or that tag as it come in would have to be maintained across this link. Okay, I'm back. So that tag would have to be maintained all the way over to here. Now, once S3 decided that it needed to flood that broadcast out VLAN 10, when it went out this access port, the tag would be removed. So on these trunk links, so on a trunk, tags are maintained. Tags are kept, I'll just say kept, okay? Except for native VLANs. On native VLANs, the tag is removed. So that is one of the native VLAN on a trunk link is untagged. And it's kind of a legacy thing that we don't really need anymore, but we still have to set up and it has to match because otherwise we'll get error messages with, from CDP. So the trunks have to be used between switches to maintain tags so that you can carry your VLAN information between different switches. All right, so as we move forward here, well, I'll try to move forward here. There we go. So broadcast domains with VLANs. Let's run this real quick. You'll notice without VLANs, look what happens to the broadcast. It goes out every single interface except for the one it came in on. So layer 2 broadcast. By the way, layer 2 broadcast goes to the all F MAC address. FF, I just call it the MAC address. If we implement VLANs, okay, and a broadcast comes out, it will only go to the interfaces that are in the VLAN associated with that VLAN. In other words, again, it comes in tagged, or it comes in untagged here. It gets tagged as part of VLAN 10. It maintains that tag across this trunk link, maintains that across here, and then as it starts to go out, it has the tag removed and it's broadcast out on this particular interface. ISL uses a different format, but this is 8021Q, and 8021Q has a tag that is placed into the frame. So you got destination MAC, source MAC, and then you put a tag in, and that tag has a type, and you can go down and look at the different types of fields in there. Type's a 2-byte field, telling you what type of tag it is. So in this case, it's 8021Q. And then a user priority, so if you do level or service implementation, so it's a quality service item. The CFI, which is used only if you're using token ring. And then there's the actual VLAN ID, which can be up to 12 bits in size. So it supports up to 4,096 VLAN IDs. You'll notice that after the tag is inserted, it does recalculate frame check sequence because that would change the FCS if it did not redo the frame check sequence when it placed the tag into the frame. But this is, I mean, basically, you're gonna see in here, if you look at the tag, you're gonna see in here, you know, if it's VLAN 10, then it would be VLAN 10 in this particular ID, and so you'll be able to see that, and that's what's maintained across the trunk links. That's how you know, or how the switches know what items are associated, or what frames are associated with what particular VLANs. Any questions? Okay. Now, this is probably the most confusing thing about VLANs and trunking and tagging, and it's this concept of native VLANs. Because of the fact that even though there is a trunk link here, it used to be in the old days that you could not say, or you might want a PC that's sitting here on a hub, okay, on this trunk, and that PC on the hub is going to have untagged frames. So you would have to set a native VLAN on that particular link. So let's imagine that this PC was part of VLAN 30 or whatever. It's on the subnet that's VLAN 30. You would have to set the native VLAN on each one of these right here to 30, so that when traffic for VLAN 30 went out onto this link, it would be untagged. Otherwise, it would actually be too big. When it got to the hub, it would be too big because of the tag that was inserted. So, quite honestly, this day and age, we don't have to worry about that much, because on our trunk links, we're not going to have that. What we need to do is ensure that on our trunk links, we set the same native VLAN on both sides, and many times we create a VLAN that's not even in use and set that to be the native VLAN on each side. Or you can just use native VLAN 1, which is by default what it is, and just make sure that none of your ports are in VLAN 1 and you're not using VLAN 1 for anything on the network. So native, if it's configured as native, it will be untagged on the trunk link. By default, all traffic is tagged on a trunk link, but if it's native, it is untagged. Where you get in trouble is when you set native on this side to 30, and this is left at the default of 1, and so this switch is sending out frames untagged on VLAN 30, but this switch expects them to be tagged, and it's sending out 1 untagged, and this switch expects 1 to be tagged. And that's where you get a native VLAN mismatch, and CDP will make you very quickly aware of that. Here we see the voice VLAN tagging. There's a phone ASIC and a phone switch, 3-port switch on the phone. Basically all voice traffic when it comes in, depending on how the config is on the switch, which it will download off of the call manager, it will decide, it will tell you what the VLAN, voice VLAN is. Also, you set that on the switch itself, S3. But you can set what the voice VLAN is, and it will tag voice traffic as VLAN 150. What actually ends up happening is you create a trunk between S3 and the, there's a trunk right here set up automatically. I got to do wrong here. Didn't click fast enough. There's a trunk that gets set up right here, and then all voice traffic is tagged with 150, and in this case, all data traffic is tagged with 20. And then you can also do quality of service based upon those VLAN tagging so that the voice traffic gets priority over the data traffic. And here you can see it to do a show interface, FA018 switch port. You see the access mode VLAN is 20, okay, voice VLAN is 150, so the data is 120 and the voice. And you see here the native VLAN is 1, so you can in this particular link. Okay, ranges. Well, there's normal range VLANs, which are basically 1 to 1005. And you've got extended ranges to go above that in case you need more. For the switches that we work on, 1 to 1005 are what we'll be using. 1002, 3, 4, and 5 are set aside for FIDI, Token Ring, FIDI-Net, and TRNet. So these are really reserved. So how do we create a VLAN? Very easy. You go into global config, type VLAN, VLAN ID, the number, name it, and that's it. Now, here's the important thing. Remember, creating the VLAN does not put any ports into the VLAN. All it does is create the VLAN. If you want a port to be associated with a VLAN, you have to make it an access port, and you have to put it into the VLAN itself, and we'll see that in just a second. These VLANs get stored in a special place called VLAN.dat, which is in the memory, so the flash memory of a switch. So we go configure terminal, VLAN 20, name student, and end, and then that will create it. And then we have to go and put the ports into the correct VLAN. So here I'm just going to have, they're creating the VLAN 20, all right. On older switches, you actually did this outside of configuration mode, but now you do it inside of configuration mode. Here's an example of making multiple VLANs, VLAN 100, 102, 105, 107. Of course, you would have to go in and name them if you wanted to name them. But then you need to assign the ports to the VLAN. So you go interface, whatever the interface is, set it to an access because you want this to be where you're going to put a host. This is not going to maintain tags when it leaves the switch. But when it comes in, you want it to be tagged with a certain VLAN. So you do switch port access VLAN, and then the number of the VLAN that you wish to have that port associated with. So switch port mode access, switch port access VLAN 20, and now everything that comes in from the student PC, when it comes in, it will get tagged as part of VLAN 20. And that tag would be maintained if this was a trunk link. Okay. So here's each pod with IP phone. It's got to support the VLAN traffic. It's got to support a trunk right there, which they will actually establish a trunk by default. So you see here, VLAN 20 named student, VLAN 150 named voice, and then switch port mode access, switch port access VLAN 20, MLS quality of service. This is doing the quality of service for the voice traffic, and then switch port voice VLAN 150. And you would have to do a lot more with it to get. Keep having video trying to play on my. Okay. Sorry. I got ghosts in the machine here. You still got to do other quality of service configuration to make that work. That wouldn't be the only thing you'd be able to do. Now, if you wanted to change VLAN membership, you could do no switch port access VLAN and then do switch port access VLAN and change the membership of a particular port so that it will move between different ones. I see this all the time where people actually create a VLAN and then don't put any ports in it. But here we have an example of moving the switch port over to VLAN FA011 over to VLAN 20. Show VLAN or show VLAN brief. Those are all commands that will show you your VLANs that are on the switch. So we're going to show VLAN brief, and you can see all ports and the VLANs have been created. If you want to delete a VLAN, you just go into global config, type no VLAN and the ID. Be aware if you have ports in that VLAN, when you delete it, you will orphan them, and that will end up causing the ports to go into an amber state because they're now associated with a non-existent VLAN. You also need to be aware that even if you delete a VLAN, the flash, or if you remove you remove the running config or the startup config from a switch, you don't delete the VLANs by default. Those VLANs are stored in a file called VLAN.dat. So if you want to reset a switch, you have to do an erase startup config, and then you have to do a delete /VLAN.dat. Make sure you don't type erase /. Do delete /VLAN.dat. If you do the other, you will erase the contents of flash, and you can lose your iOS. So delete /VLAN.dat, and then you reboot, and that will get rid of both the startup config and the VLAN.dat. If you ever sit down on a switch that you think's been erased and it's already got VLANs on it, what happened was someone erased the startup config, but they forgot to delete the VLAN.dat. Very common in the classroom, happens all the time. So show VLAN brief, show VLAN ID, just the VLAN itself. You can do it by name. You can look at the interfaces to see the information on the interface. So show VLAN name student. I'll show you the just the student VLAN and the ports in it. Show interfaces VLAN 20. I'll show you VLAN 20, what that interface is, if it's up, if it's down. By the way, VLAN 20 will not come up until there's a port actually in the VLAN. So even if you do VLAN 20 name blah, and you don't have a port in it and that port's not up, then the VLAN will not be up, which confuses students many, many times. So now let's talk about our trunk links. We've talked about the fact that an access port does not maintain tag information when a frame goes out it. So an egress frame does not maintain. On a trunk link, tags are maintained for all VLANs except the native VLAN. We're not going to talk about DTP right now. It is actually part of the curriculum later. DTP is part of scaling networks, and we'll talk a little bit about it later, but dynamic trunking protocol is the reason we have to put in the switch port mode access command. By default, the port has DTP running on it, dynamic trunking protocol, and two switches, when you connect them together, they will actually try to negotiate a trunk, or they can try to negotiate a trunk using DTP. If you use switch port mode access, it turns off DTP, and you do not have to worry about DTP forming a trunk by accident. If you want a trunk, the best thing to do is just make a trunk. So do switch port mode trunk, set the native VLAN if you want to get it off of VLAN 1, and then you have a command that you can set to allow only certain VLANs. Now, by default, all VLANs are allowed, but if you wanted to only allow the VLANs that you created, you could do that. Just be aware that if you create 4 new VLANs, you're going to have to go into every one of your trunk links and add in the ability for those VLANs to traverse your trunks in your network. So here's the topology. We've got VLAN 10, 20, 30, and 99. 99 is our native. They're actually using their management as 99. So we'd have to go into our trunk, and we do switch port mode trunk, switch port trunk native VLAN 99, switch port trunk live VLAN 10, 20, 30, and 99. Now, if we do that on switch 1, we would have to do the exact same thing on switch 2, or in order for it to create a trunk link with switch 1. And .1Q or 8021Q is the tagging method we're going to use pretty much in the real world out there. All right. Now, if you want to reset a link or a port not to be a trunk, you do a no switch port trunk allowed VLAN, no switch port trunk native VLAN, and then no switch port trunk or switch port mode access, one of the two. But you need to take those off first in order to make that work. So no switch port trunk allowed, no native, and then you could go back and turn it into an access port. Switch port mode access, which will turn it back into an access port. So verify trunking, show interface trunk. That's what I always use. You can do this too. You can do show interface FA01 switch port, and it will tell you whether or not it's a trunk. I like show int trunk because it shows me everything that I need. And here they've got it showing you just doing that. That's just you can look at it. The show interface trunk is what I use to see the trunking. Now, what are issues? Really, the big issues with VLANs are the following. You create your VLANs, you forget to put your ports into the correct VLANs, or you put them in, don't put them in a VLAN at all. Number two, the other thing to remember is this. Remember that a VLAN equals a network. So, in other words, VLAN 10, in this case, we said it's got 172.10.21, but over here it was actually supposed to be 172.17. Every VLAN is its own subnet or network. So, because you put the wrong IP address on this, even though the port might be in the right VLAN, they may be allowed across the trunk right here. You know that you got your trunk, everything's good. Because you're not on the same subnet, they're not going to communicate with each other. In other words, you've got layer 2 connectivity, but you do not have layer 3 connectivity because you've created a problem with the IP address. So VLAN equals network. Remember that. So there's the incorrect IP address on this one, so you could change the IP address. A missing VLAN. So in other words, you didn't put a VLAN in, or you assigned a port to a non-existent VLAN, or even worse, you deleted a VLAN. So you can have a missing VLAN. Trunks. Most problems with trunks are one side set to a trunk, the other side not, or the allowed VLANs are not the same, or that does not allow a VLAN. This occurs many times when someone sets up a network, they set up their trunks, they have set allowed VLANs, they come back 3 months later, they put in 4 more VLANs, and they forget to change that. And so those are not allowed across the trunk link. So here's where you can do show int. If you just do show int trunk, we'll actually show you the mode and show you what the encapsulation is and the status needing your native VLAN. So native VLAN mismatches, that one port has 99, one has 100, or one in whatever, either one. One side is a trunk, one side is not. Remember what happens then is one side will continually try to tag the traffic while the other side expects it to be untagged, or your allowed VLANs are not the same or correct. You could have an incorrect mode. Now, I will tell you this. Here's something I want you to be aware of. The curriculum only shows trunks between switches, but in our world today, let's imagine I've got a server out here, and this is my VMware server. Okay, so this is VMware. It's running ESXi. It's got vCenter on it. It's got all those things. There's a very good chance in today's world that we're going to have, well, we'll have a trunk link right here to get to our VMs. So it's worth teaching your students that trunks don't exist just between switches. Trunks do exist between switches and servers, especially in the data center. Now, typically, going out to end host, these are access ports, but that is not always true. Sometimes we trunk out to our servers so that we can have multiple VLAN traffic or servers on multiple VLANs on the network itself. That's a little beyond the scope of what we do in this course, but it's good to know because, again, it is something that's out there in the real world. And this was a case where they had a port set to access when it should have been a trunk, and, of course, that's going to cause a major problem. Incorrect VLAN list, so not allowing the correct VLANs. So we got VLANs 10, 20, and 99. We forget 30, or we forget a VLAN that is needed. In this case, switch 1 is only allowing 10 and 99. It's not allowing 20. So that is a common issue when doing allowed VLANs. And that's what those troubleshooting items are on for VLANs. Now, I told you that VLANs equal network. So if I have a switch that has multiple VLANs on it, let's go back here and look at this picture right here. Okay, let's just imagine, I'm going to go here. Imagine this. So we've got VLAN 10, VLAN 20. even if it was completely configured correctly, is there any way, if these are all layer 2 switches, is there any way for VLAN 10 to talk to VLAN 20? There's no layer 3 device, so there is no way for VLAN 10 to talk to VLAN 20. So, in order to talk between VLANs, we must have a layer 3 device. Now, we're going to talk about legacy inter-VLAN routing, and we're going to talk about trunking to do or modern routing, and we're also going to talk about switch virtual interfaces. But in legacy inter-VLAN routing, what you have is you've got multiple VLANs, and then you've got ports in each one of those VLANs. So on this picture here, the FA011, FA01, all these ports are in VLAN 10. So they're in the 172.17.10/24. We're just going to say /24. I don't know if it's /24, but I'm saying it is. And then all these ports over here are on VLAN 30, and so they're /24 on this side. Now, you should be able to very quickly see that one of the issues with this is that if you have more than 2 or 3 VLANs, you very quickly will run out of ports on your router because routers do not have an unlimited number of gigabit ports on them. So, legacy inter-VLAN routing, while useful, okay, is limited because it's not very scalable. So you have to go across. You've got trunking down here on the unicast. This is coming up for VLAN 10. It's tagged. It will actually go out and untagged because this is an access port. FA03 is on VLAN 10, but it's an access port. So there are no tags in this legacy inter-VLAN routing. No tags being maintained between switch 1 and R1. Okay, so everything is being used across access links up to R1. Again, that's not very useful because you've got to use multiple interfaces to go all the way through. Now, this is not routing on a stick. I don't know why they've done it like this, because we need a router on a stick, which we're going to look at it like this right here. So that's legacy inter-VLAN routing, and we'll show you this. Basically, again, it's that same thing. You're going to create 2 interfaces, and the interfaces will be on the router in 2 separate networks, and then the ports on the switch will be assigned to VLAN 10. So it'll be VLAN 10 for 4 and 11, and 05. And so traffic only maintains the tag inside the switch, and will go up and then back out on R1. Again, a huge waste of resources. Well, there's an advantage here, though. One of the advantages is you do have a full gigabit link for each VLAN. So if you only got 1 or 2 VLANs, it may be worth it for the traffic to be able to move across there quickly. With router on a stick, we create a trunk link. So we create sub-interfaces on R1, and we share across that one link. We maintain all the tags. So the information is tagged. It's a unicast frame from VLAN 10. It's coming in. It goes in. It comes in the gig 00.10. That's how it's handled. And it gets rerouted back to the other gig 0.30, 00.30. To come back, be tagged with VLAN 30, and maintain the tag all the way back out to PC3. The bonus is, or the good thing is, you're only using one link in order to support all the VLANs that are being routed by R1. The negative is all of those VLANs are sharing the bandwidth on that one particular link to R1. Configuring router on a stick, this is what we would do. We'd create a trunk. Okay, so we'd make 05 a trunk, and then we would create sub-interfaces on gig 010. So, or 00, you see this right here. So we go interface gig 00.10, that's a sub-interface. Encapsulation .12, and then the 10 is the VLAN you're associating that interface with, so that's your tag. Then you put your IP address, and you do gig 00.30, and then .1Q30 and IP address, and then you've got to go to the physical interface and set the no shut command, and that would bring up the 2 sub-interfaces. And you can add as many sub-interfaces as you want. I think the limit that Cisco sets is around 4 million sub-interfaces per physical interface. Obviously, you would very quickly overwhelm your capacity on that link if you did that. You also have the ability to set native if you want to set one of these to be native. So let's say for some reason it was 99 and it was native, the encapsulation.1Q 99 native. That would set the native on that link with that switch. Then you can do show VLAN on the router, and you'll see the different VLANs, so VLAN 10 in the IP address and VLAN 30. It'll show you those sub-interfaces that have been created. And when you do a show IP route, you'll actually see those in the route table as being on .10 and .30. So again, let's look real quickly here. We're going to go into the interface and create sub-interfaces. Using encapsulation.1Q, that's the tagging method. And then the VLAN is associated with an IP address on it. And then you will go through and do a no shut on the physical interface to bring that interface up, or all the sub-interfaces up. If you want to verify route on a stick, you just do pinging. You can ping and you can trace route and see where it goes. And that's pretty much route on a stick, folks. And quite honestly, that's pretty much this entire chapter for VLANs. Okay. The one thing we're going to talk just a little bit about is, and they don't really talk a lot about it, but I want to talk just a second about it. Open up a Word document here. If you have a layer 3 switch or a switch that supports layer 3, you can create multiple switch virtual interfaces. In other words, you could create the interface VLAN 10, put the IP address of it of 192.168.10.1/24, and then you could do interface VLAN 20, and then put 192.168.20.0/24 on it, and then you can take actual ports and put this port into VLAN 10, and this into VLAN 20, and then the switch itself, if it supports layer 3 routing, it can actually route between these switch virtual interfaces. All right, so that's what's called multi-layer switches, or MLS. Multi-layer switches, they can actually do layer 3 routing using the switch virtual interfaces. And that's mentioned later on in some other items, some other things we have that's not really mentioned in this particular chapter. Folks, that's basically VLANs in a nutshell. Are there any questions on VLANs? Okay, John, you good?
Yeah, I'm good.
Okay, well let me, that was John, sorry. I'm going to stop sharing real quick, and I'm going to stop my recording.